Good afternoon. Thank you for attending this flash talk despite the title. Abstraction in EdTech versus Computer Science Education Standards sounds like a real snooze fest. It screams, I need my caffeine and sugar, or at least a nap. But I promise it'll be worth the next 12 minutes or so. As for me, I'm Lawrence Tanimoto, and although I'm retired, I stay active as the VP of Communications of CSTA Washington. If you want the latest version of this presentation, it is on the CSTA Washington website, cstawa.org. We will also revisit this blog post at the end of this presentation because it contains several surprises. Quick audience poll. Of the 4 computational thinking concepts, which is the most difficult to teach? Can I get a show of hands? Is it decomposition, pattern recognition, algorithms, or abstraction? Of course, the title of this talk gives the answer away. But here are the results from a poll of elementary school teachers from a paper presentation that was one of my inspirations for this talk. Abstraction is overwhelmingly the most difficult of the 4 computational teaching concepts to teach. And how about you? Another quick audience poll. Show of hands, please. Do you feel that you teach abstraction in CS well? Do you feel that you understand CS in abstraction well? Well, no matter where you fall on the spectrum of these 2 questions, this presentation is for you. So thank you again for attending. But why is teaching abstraction in CS so hard? One thought I had is, abstraction is an art, not a dead artist. Just think about that as I continue with this presentation. So now let's talk a little bit about EdTech and CS standards. Why does the difference between these 2 standards matter? Well, EdTech standards are about technology literacy and fluency. Computer science standards are about computing systems and problem solving. Many educators and legislators often conflate the 2, but students feel the difference later. Students may become proficient users of technology, yet they never really understand the computing systems that make it possible. Now let's go back to standards, right? One great thing that the CSTA Standards Committee did for the 2017 standards that I hope they do for the new standards is to produce a progression chart that shows the standards according to concept, subconcept. And a great thing that the EdTech community of Washington did was to create a crosswalk document showing how the national EdTech standards cover the standards of so many other subjects, including CS. The CS standards that are covered by the EdTech standards are shaded in light green in this document. And I apologize to the accessibility people for this slide. Now, a quick visual analysis of this crosswalk document would show that the concept of variables is completely missing from the EdTech standards. And the concept of variables is a key abstraction idea. Right? This analysis of standards, right, that we just did, the 16-to-1 poll shown earlier, and comments that I've heard from both colleagues and students alike over the years, were really telling a story that we have been overlooking. A story about the one idea that underlies almost everything in computer science. And for me, at least, it's all about abstraction. Actually, it's about multiple layers of abstraction. Why abstraction matters. Now, every modern computing system runs on layers of abstraction. Each layer of abstraction hides terrifying complexity below it. Without abstraction, modern software would be impossible. And without teaching abstraction at all, AI essentially becomes magic. Layers of abstraction reveal the magic behind AI or below AI. In this particular diagram, each layer is an abstraction of all the layers below it. And each layer here actually contains several layers of abstraction within itself. And each layer, although relatively simple in itself, hides a terrifying amount of complexity below it. Without an understanding of abstraction, AI totally feels like magic. And any sufficiently advanced technology is indistinguishable from magic, right? From the famous quote. But abstraction is a bridge. Abstraction helps explain why all students need to learn some computer science, but not everyone needs to major in it. Abstraction in CS provides a literacy between math and natural language. Abstraction provides the bridge between humans who know what they want, even if they can't do it well, and computers who don't know what they want to do, but do it incredibly well if given the correct instructions. Of course, let's not get into AGI here. You can see EdTech mostly lives at the top layer of abstraction. The top layer is using AI and applications, and our students need to learn that. Computer science is how each layer of abstraction works. Each layer of abstraction itself is not that complicated, but building upon multiple layers of abstraction makes the magic at the top layer happen. And students need to learn both, deserve to learn both. I hope that this talk has changed the way that you think about abstraction in computer science. While I've talked much about abstraction in the abstract in this presentation, pun totally intended, for this talk, I've also created my first creator mode video with concrete examples to help you better understand and explain the power of abstraction to your students. This 7-minute video is on the CSTA.org blog post that I mentioned at the beginning of this session, along with a copy of this slide deck and other resources. Please share this video with your colleagues and students. If the video helps one more teacher make abstraction understandable for their students, then it was worth creating. We will use the rest of the Flash Talk time watching the video. Thank you so much for attending this Flash Talk. If you have any questions, we can talk in the aisle behind the Flash Talk area. Otherwise, please enjoy the video and the rest of this marvelous conference, and be sure to get some protein and fiber along with your caffeine and sugar at the snack area.